Hello students, how are you? My name is Kенжеқұлқызы and I'm your new teacher. And our new topic will be the vector and their elements. What do you know about vector? Where we can find them? First of all, we need to start with the values. We have different values in our world, like the mass, speed, and direction, yeah? And we have the quantities to help us to differ them. First quantity is called the scalar quantities. The second called the vector. What is the difference between them? The scalar quantities have the only magnitude values. Magnitude. Where the vector had a directed magnitude. Vector have a direction. Directed magnitude. And here, let's take example with a bus. We have one bus from Antalya to Berlin. Yeah. And we have two quantities here. First of all, the direction and the distance. Distance between Antalya and Berlin will be the length of the vector, and direction will be also the vector. Of course, and definition will be what? The vector is a directed line segment in the plane. Line with an arrow, just an easy, or directed line segment. And here we have the length of the vector. How can we write it? Just in model, name our vector like the AB and write them 2 centimeters. And how can we write the vector? Within capital letter like the AB and within lowercase letter AB, and we must write the arrow on the top, or the U vector. For example, the A will be the initial point and the B will be the terminal point of this vector, and the U vector and the V vector. We have the types of the vector. The first one will be the equal vector. Equal vector. What is the equal vector? Equal vector called equal when they have the same direction and also the same length. U vector and V vector here. They are equal because they have the same direction and the same length. And we can write them like the equal. We have example with an equal vectors. First example. And given ABC triangle, ABC triangle, and D, E, and F are midpoints. Our triangle is equilateral, and DE is parallel to BC, and EF is parallel to AB, and DF is parallel to AC. Here we need to name all the equal vectors. Equal vectors, yeah. How can we solve it? We said that our D and F are the midpoints and it's an equilateral triangle, and vectors will be DE, B, C, and the side of the will be the vectors also. And of course, the solution will be that DE is equal to BF and FC because it's parallel, yeah? And EF side will be equal to AD side and DB side also. And DF side will be equal to EA side and EC side. The vectors will be the same and they will be, of course, equal. Let's write the first one, just DE vector is equal to BF vector and it equal to FC vector. And the second one will be AF vector is equal to AD vector and DB vector also. Okay, I think another one you can write and show. It's easy. We said that we have the different types. The first one and the first one was the equal vectors, and the second one will be the collinear vectors. What is a collinear vectors? Collinear vectors are the vectors which laid on the same line and have the same direction and the parallel. Vectors called the collinear. We have a line here and two vectors here, like the u vector and the v vector. They are collinear because they laid on the same line and have the same direction, and they are parallel. For example, this one here, maybe again the v. And the non-collinear will be just the opposite of this definition. The third one called zero vector. Zero vector, just the vector without any shape and length, just the point. And it will be right as 0 with an arrow on the top. And the first one will be the unit vector. Unit vector. What is it? The unit vector is the vector which is equal to the 1. For example, a vector is equal to the 1. That's all with the definition. Our vector helps you to achieve your goals. How? If you want to achieve a goal, you must be like a vector. For example, the AB vector, yeah, here. Our AB vector has a length, which is equal to, for example, 2 centimeters, yeah. We can write the length as in model. First of all, you need to write the name of the vector and the centimeter maybe. And it has a length, which means in our life the effort. Without any effort, you will be just the zero vector, without any shape and without any direction, just the zero vector. Without any process, without any development. If you want to be like the zero vector, you must try and you must do it right now. Is the second part of the vector separations, and today we will have the addition method and the multiplication method. So here, the first one will be the addition, yeah. The addition method have the polygon and also the parallelogram method. The parallelogram method. We will talk about the first one right now, the polygon method. Let's say we have the PQ and QR vectors, yeah? We want to find the sum of these vectors. We will find them by the polygon method. Let's call it example, yeah? And we have our CD vector. C will be the initial point, D will be the terminal point, and AB vector here. Let AB and CD be two vectors in a plane. So here we will place them the point and the terminal point together. And the initial point of the AB, and the terminal point of the CD, this one, yeah, to make DE together. So it will look like that. The terminal point of the CD and the initial point of the AB. And the other side will be like the CE. It will be C, D, and E. Using the polygon method, we can say that CD vector, the sum of the CD and the AB vectors is equal to CD vector plus DE vector. And at the end, it will be equal to CA vector. And our answer is our CA vector, like the connection vector of this polygon method. In this polygon method, we need to find the connection. Just connect the first vectors and just end the polygon with the other vector. So our answer is CE. In that example, you need to find the sum of the vectors by the polygon method. The second example, we have the U vector here, also the X vector, the V vector, and the W vector also. How can we connect them? Just put the initial point and the terminal point together. U vector, it will be the first, the second name. The U vector, and connect the initial, not the initial, the terminal point of the V, and connect the terminal point, of the X vector, and the other side connect, with like the connection vector. Like that. So it's our W vector, this one, and here it will be D, and this one will be E. And we find that our sum of the U, V, and W and X vector is equal to what? A, D, E, D, E. The second method, called the parallelogram method of the addition. The second method, parallelogram method of the addition. Imagine you want to add the PQ vector to the QR vector. Find the sum of this, How can we find them? We can find them by connecting the initial points of these vectors. So, like this, we can show you an example. For example, you have the U vector and the V vector, here. How can we connect them? Just connect the initial points again. Initial points of the U connect with the initial points of the V vector. And the parallelogram with the other sides. The third one will be, again, draw those vectors, U and V, and the fixed point where the connection vector will be the R, and we find that our U, the sum of the U and V vector is equal to the R vector. Here we have third example. You need to find the sum of the V vector here, U vector, and the W vector also. The W vector. How can we find them? Again, just put the initial points together. The solution will be, A will be the fixed point here. The initial point of the U, initial point of the W, and the V. Connect this one like this. I know that it doesn't look properly, but I think you will understand it. Connect the other sides again to form a parallelogram. Like this, And we said that our A is fixed point. Here, this line, this one, this one will be the sum of the U, V, and the W vectors. Let's call it just like the G vector, maybe. Our sum of the U, V, and W vector is equal to the G vector. We have the multiplication of the vectors, so here, if the scalar of the number is greater than 1 or greater than -1, our vector will be longer. If our vector is less than -1 and lay on the between 1, non-zero, and -1, it will be shorter than the first one, vector. So here, if our vector or the number, our number will be A, value will be A is greater than 0, our vector is longer. If our value is less than 0, our vector will be shorter than the first one. And let's solve the first example together. We have the AB vector here, and we need to find using this AB vector, draw vectors like 2 multiplied by AB, 1 over 2 AB vector, and minus 4 AB vector. How can we draw them? The first one, we see that our 2 and 1 over 2 is a positive. So it will be what? Of course, it will be changed, changed to the longer, because our 2 is greater than the first one 2 times. So how can we draw it? Our first vector looked like that, and right now it will be look 2 times longer. 2 AB vector. And the second one was the 1 over 2, 1 over 2 AB vector. How can we draw it? 1 over 2 is like the half, and our first one vector look like that, and the half of this vector will be like this here, and it will be just this one, 1 over 2 AB vector. And the third one is a negative, minus 4 AB vector. Here we see that it's a minus 4 value, If we have the minus value or the value which is less than 0, it will also change the direction. The first vector look like that, and it has the direction which is placed to the right, to the right side. And here it will be changed to the left side. And it's 4 times longer. 4 times longer. And our vector is look like that. Yeah, great, we have done. We have the same properties of these multiplying vectors, like the rules, And we have the A and B. A and B here will be the value or the scalar or the number. A multiplied by U vector is just the vector, okay? The second one, if we have the multiplying by 2 numbers and multiplying by a vector out of brackets, we can just write it like the A1 number or the scale will be out of the brackets, multiplying by B, multiplying the U vector. And third one, if we have the sum of the 2 numbers multiplying by vector, we can write it just individually, Open the brackets individually, where A scalar will be multiplied by U vector, and the B vector will be also multiplied by U vector, and the symbol will be the same as in the brackets. The first one, like the rule, if we have the sum of the 2 vectors and multiplying by a scalar, we can write it like A multiplying by U plus B multiplying by V vector. B is the another value here, the fifth one. When 1 is multiplying by U vector, it gives us only just 1, If 0 is multiplying by a vector, by a vector or the U vector, it doesn't matter, it gives us 0. So let's practice with another example 5. You need to find here the solution, the answer, and draw it with the other vectors. We had vector x here, we had vector y here, not y, and the z vector, the vector here. And the given is 2 multiplying by x plus y vector plus 1 over 2 z vector multiplying by z vector minus 2 multiplying by y vector plus the x vector. How can we solve it? Just an easy using by these properties. Solution, The solution. Just open the bracket with the properties. 2 will be multiplying individually as in the third properties. Multiplying individually. 2 multiplying by x plus 2 multiplying by y vector plus z will be the same, 1 over 2 z vector. And here we have the minus out of brackets, and will be changed the whole symbol in the brackets. So open, just open, minus 2y vector minus x, change the symbol. Yeah? And here, just simplify, we have the negative and the positive y, so just simplify, and the x also. It will give us just the x vector plus 1 over 2z vector. Our first vectors looks like the x, y, and z vector. Yeah? We don't need the x vector because x will be the same and y vector. So here we need to finally need the z vector. Yeah, 1 over 2 z vector. 1 over 2 is like the half. We had the first one. It's look like that, and the half of that will be this. The half of the z vector. 1 over 2 that m, and we need to connect them using the addition method because we have the sum of the x vector and the z vector here. By using the polygon method, how can we find them? Let's take the x. The terminal point will be connected with the initial point of the z. It's the x vector, the initial point of the zm. 1 over 2z. 1 over 2z. So we had to connect the other, and this side will be the sum of the 1 over 2z. Or we can just name it like the r vector. So the answer is x, sum of the 1 over 2 and x vectors is equal to r vectors. So we have done. I think you understood our new topic. Subscribe to our channel. So thank you for your attention and goodbye.